minus 20.
Okay, now we're getting into factoring.
Mm-hmm.
Now, have they taught you a method that they attach a name to it? Have they taught you the California method or the diamond method or?
Yeah, they tell us to put it in a chart, like a times c and then b equals, like in this case, negative x.
Okay. Do you like that method?
Yeah, it seems to really help me.
Okay.
Yeah.
Tell me how you would do this one then.
So it's like a t-chart. So it's a times c, then b equals negative x. Yeah, so a times c in there.
A times C there?
Yeah, and then b equals negative x in this case.
Where does B go?
In the second chart, or like in the second column. Yeah, right there. Yeah.
Okay, so B is minus X. Okay,
Mm-hmm.
now what do you do?
So you do, so x squared, there's just a 1 in front, so you do 1 times negative 20 equals negative 20. And then 1 plus negative 20, or 1 minus 20, equals negative 19. And then you want to try to find what's in the, so since b equals negative x, you want to find a number that equals negative 1.
Okay.
So, what else could we do? Oh, we could do, let me think.
As long as you can come up with the answer, I'm cool with however method you want to use.
Okay.
I have my own technique for factoring that I prefer tremendously over this method.
Okay.
But I don't want to confuse you, and I have other students that learn this method and they prefer this method. So as long as you can come up with the answer, that's the only thing that really matters.
Okay. Alright, so for this one, yeah, so we could do negative 5 times 4. And then negative 5 plus 4 equals negative 1. So there are two parentheses, so it'd be x minus 5 in one. And then x plus 4 in the other.
You got it.
Cool. And then the second one is m squared minus 6m minus 7. And then they're both n's. Sorry, I forgot to. It sounds like I'm saying n.
It's just I don't hear that well. And it doesn't really matter what letter we use.
No. Okay.
Quadratics, you can use any letter you want, as long as it's the same one. But it can be R, S, X, Z, anything you want. Okay?
Okay.
So what's the rest of it?
So first a times c, so 1 times negative 7 is negative 7.
So 1 of them is minus 7?
Yeah.
In other words, I'm so unfamiliar with this T-chart that
I guess,
I'll let you do it and just give me the final answer.
Okay.
As long as you get it, that's great.
Okay.
What goes in the second one?
Yeah, so this one would be x plus 1 in 1. And then, or my bad, m plus 1. It doesn't really matter though. And then m minus 7.
That's correct. Yeah.
Cool.
Okay.
Okay. And then this one, so it's negative 16 minus 16 plus t squared.
Okay.
Alright, and then let's make the chart.
The way I would do this, I would put it in order first.
Okay.
In other words, I would put the t squared there.
Okay.
And that's the more traditional way that you have quadratics.
Okay.
Once you put them in order, now it becomes relatively easy to factor.
Mm-hmm.
It's pretty hard to factor if you leave this t squared over there on the right. At least it is for me.
Mm-hmm.
With that method you're using, it might be just fine to do it that way.
Mm-hmm.
But
okay. Mm-hmm.
So
okay, so for this one would be x or t minus 4 in both of them, or just t minus 4 and then t plus 4.
Well, what happens if we do that? Let me at least avail you of my wisdom in terms of checking your answer.
Mm-hmm.
Okay? In other words, we want to multiply this back together again to make sure that it's equal to what we started with, right?
Yeah.
Okay.
Mm-hmm.
Well, I know the t squared is correct.
Yeah.
I know the minus 16 is correct. So the only term I always need to check is the middle term. And you get the middle term by multiplying the inside terms together and the outside terms together. When I multiply the inside terms together, I get plus 4t. Multiply the outside terms minus 4t, add those two together, that would be my middle term.
Yeah.
So this isn't correct, the way we factored it.
No. What about, negative 8 times negative 8, or plus negative 8?
8 and 8 would give you a 64 here. So the numbers we want have to be factors of 16.
Okay.
But they have to subtract to the number 6.
Okay.
So what two numbers multiply to 16 and subtract to 6?
Oh, 8 times 2.
Okay. Where's the 8 go?
Negative.
Where's the 2 go?
So it'd be t plus 2, and then t minus 8.
There you go. Okay. Now, if I'm concerned as to whether I got it right now, again, I don't have to check the t squared. When I do my thing, I base it all on this term and this term, so I know those two are right. But if I do what I call my double smiley faces, I got plus 2t there, minus 8t there, add them together, minus 6t. That is my middle term. I've done it correctly.
Okay, cool. Okay. And then we can do x squared plus 8x plus 7.
Okay.
Yeah. And then this one, if you make the chart, you can just do 1 plus 7, or 1 times 7. So it would be x plus 7 and then x plus 1.
Correct.
Okay.
You want me to make those up?
And then...
if you have some to practice, let's do it. But I can also make some up.
Okay, yeah, sure, because I don't really have much more on my homework besides that.
Okay. Actually, let me grab my book.
Okay.
Now, have you had to factor anywhere the first term is not a coefficient of 1?
Okay, yeah, I don't think we've done that yet.
Haven't done that yet? Okay.
Yes.
So we don't want to look at that. Hold on a moment.
Okay, yeah, no problem.
Chapter on factoring. And then, because it's pretty easy to make them up if that's a 1.
Yeah.
Once it gets to be a number other than 1, that factoring becomes kind of hard.
Yeah.
All right, here's a bunch of them.
Okay.
And you say you have not had anything like this.
Oh yeah, we've had stuff like that. Yeah.
Yeah?
Yeah, we've done that. My bad.
Okay.
Yeah.
Well, let's do some of those then.
Okay,
Hold
cool.
on.
Okay.
Yeah, all right. Here's one.
Okay.
I tell you what, you got the right idea. With factoring, you can never do too much practice.
No.
Factoring gives most people quite a bit of trouble, and the way you get good at it is just practice. Practice, practice, practice. It's like anything else. But factoring in particular.
Okay. Actually, now that I actually looking at it, I don't think we've done like the 2x squared. I think we've only done like the 1x squared or like t squared.
Okay.
We've only done those so far. I think we're starting those ones tomorrow.
Okay.
Yeah, my
Do you
bad.
have a
I'm
quiz
sorry.
tomorrow also?
I might a makeup quiz maybe.
See, this one, clearly it's got to be 2x and x.
Yeah.
3 only has 2 factors, and I know the 3 goes there, and the 1 goes there, and in my smiley faces, that's plus 1x, that's plus 6x, add them together, you get 7x, that is our middle term. I've done it correctly.
Cool.
Okay?
Cool.
So, there's a more trial and error involved when you have a number here. It just presents so many more opportunities that it's harder to do. And your method might actually be superior to mine when it gets to that, although I don't think it probably is. I actually believe my method is the best method, but I have confused some people by using my method, and they're taught your method. Here, let me find some more.
Okay. Okay, so if we do the chart, let me write this down.
So all of these that you're doing are all going to start this way.
Yeah.
Chart or no chart, right? Once you have a number, in other words, if there's a 4 there, now I got all kinds of possibilities. It could be 2x and 2x. It could be 4x and 1x. But as long as it's a 1, it's always going to be x and x.
Yeah.
Okay, now go ahead and use your method to come up with the other two numbers.
Okay. Yeah, so I got x plus 1 and then x minus 6.
It's pretty good. You can do that pretty fast. Okay.
Cool.
Yeah. Let me give you some more.
Okay.
They're actually pretty easy when it's just x squared.
Yeah, exactly.
They only get hard once you get a number in front of that, but we'll tackle that when we get to it. Let's get you proficient at these.
Yeah. Okay. So x plus 5 and then x plus 3.
We need factors.
Or 4, my bad. Yeah. So x plus 4.
Hold on. These two numbers have to multiply to 14.
Oh, that's right. So 7 times 2. So x plus 7 and then
and they have to add to 9. So that's the correct answer. Okay.
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 Okay. All right.
Here's another one.
Okay.
Hold on a moment. I want to make sure I don't give you any that can't be. And this might.
No
this
problem.
might be one. Let me think for a second.
No problem.
Because I'm grabbing these from a section that it doesn't say for sure that they can be.
Gotcha.
About this. They do get a little harder when you have lots of possible factors. like 72. Let me give you a little hint on how you can factor stuff, perhaps a little easier. Tell me all the factors of 72.
Write this down. There's 2 times 36.
Why don't we start with this? Always start.
2 times 1.
Yeah, always start with the 1 times. Okay.
Okay.
Now, to get the others, one way we could do it real easily is cut this in half and double that. So when I cut 72 in half, it's 36. So that's another set of factors. And I can do the same thing again. I can cut this in half again, 18, and double this again. There's another set of factors. And I can cut that in half again, double that again. There's the other set of factors. So that's one way to come up with factors that's relatively easy. It doesn't always work. If it's multiples of 3, then cutting it in half isn't going to get there. But in this case here, and now that I have all these factors listed, which 2 do I want?
18 and 4.
Yeah, you want the ones that subtract because of that to the number.
So I got, So I got x minus 18 and then x plus 4.
Right.
Cool.
Yeah, you do seem to have that mastered. How about this one?
Okay, so here, let me write this down. B equals -8. So okay, so let me see. We could do x minus 6 and then x plus 2.
Not plus.
Or minus 2, my bad.
In other words, when you're doing these, always make sure you have this term and that term, because those are really easy to make sure you get right.
Yeah.
And maybe if I show you my technique here, it might help you just marginally. Okay? Here's what I do. Step 1, I separate the x's. Step 2, I figure out what the signs are going to be. Because that's a plus, I can only get a plus if the signs are the same. They either have to both be negative or they have to both be positive.
Okay.
I look at the middle term, it's negative. That means they have to both be negative.
Okay.
Now I'm looking for factors of 12 that add to the number 8.
Okay.
Simple as that. Notice that my second step was figuring out both signs. If that was a minus, now I would know my signs have to be opposite. You can only produce a negative number if you're multiplying a negative times a positive or a positive times a negative. So if I'm looking at a negative in front of my constant, I know the signs have to be different.
Okay. Yeah.
Now I would say, now I'm looking for factors of 12 that have to subtract to the number 8. And there aren't any.
Yeah.
So this would not be factorable by this method. In other words, if this was my quadratic, I would have to use the quadratic formula to solve it. Because I can't factor it into whole numbers. There are no 2 factors of 12. In other words, the factors of 12, if I go through my process, are those. Well, none of those subtract to the number 8. So this one doesn't work. This one wouldn't work in your method either.
No.
And but getting those signs, you don't want to make a mistake on the signs. And you never should make a mistake. because you always want to do that last check. And maybe for you, the thing you should check instead of just the middle term is the sign on the last term also.
Okay. Okay.
Find another one.
Sure.
Actually,
Okay. And 10. So it'd be x plus 1, and then x minus 10.
good.
Cool.
So, have you had to do this?
We haven't done that yet, no.
So everything you've had to do so far they're all trinomials. In other words, they all have an x squared term, they all have an x term, and they all have a constant.
Okay. Is this a binomial?
This is difference of perfect squares, is what that is.
Oh.
That always factors into x minus 5 times x plus 5. Okay. Or if it factors into, in other words, a squared plus b, a squared minus b squared is always a minus b times a plus b. And a and b can be different things. In other words, if I had x squared minus 81, then that would be x minus 9 times x plus 9.
Oh, okay. So it's just basically the opposite.
They're always opposite, and this number is always the square root of that. So, and this is always the square root of that. So this is called, those are actually called the difference of perfect squares, because that's what it is the difference of perfect squares.
Okay.
You'll probably get that tomorrow also.
Yeah, probably.
Let me see if I can find a little bit. Let me make sure you can figure out what to do with this.
Okay.
Hold on. Excuse me. Equals minus 20.
No problem.
So, first of all, let me make sure you understand. Maybe you haven't had this. If I gave you that, you'd know how to factor it, right?
Yeah.
Okay. Well, if it's an equation, the next thing you're going to learn is solving equations, where one side is a quadratic. Okay, well, if we have to solve this equation, we're going to factor this into two things. What are they?
So x in both, yeah. We did this.
This is similar to what we were working on last night. Only last night you never had trinomial quadratics. You always just had a greatest common factor that could be pulled out. Whereas here, you have to factor it as you've been doing.
Would it be x plus 5 and then x plus 4?
Correct. So now that whole thing is equal to 0.
Equals 0.
Now,
yeah. And then you can just break it apart. So x plus 5 is equal to 0.
Okay.
Then x is equal to negative 5.
Okay.
And then x plus 4 is equal to 0. And then x is equal to negative 4.
Okay.
Yeah.
So when I gave you this problem initially, I had the minus 20 on the other side, like this.
Yeah.
So the very first thing you want to do is make one side equal to 0. Okay, so if you get a problem like this, you would want to bring everything to one side and leave 0 on the other, and then solve it as we just did. And for me to do that, I would add 20 to both sides, produce this.
Okay.
Once you get that 0 on one side, that's what you're looking for, because then, assuming you can factor this thing, then you get it as the product of two things.
Okay.
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 Let me see what else I got in my book here that might challenge you.
Okay.
You sure you don't have to worry tomorrow about anything that has a number in front of it, huh?
Yeah, we haven't been taught that yet. Yeah, she said she's probably going to teach us that either tomorrow or Tuesday.
Yeah, it's definitely,
it's
definitely where it gets a little harder.
Yeah.
Here's one that might challenge you just because it's not that easy to factor this number.
Okay.
And this is an equation. Now, have you gotten to the point of, yeah, you had some of these last night. You have had these as equations, right? Like this?
We have. Okay. Yeah. Yeah. Okay, so does 19 even go in 88?
I don't know. That's not the way I do it. I look for factors of 88.
Yeah.
Let's use my method for figuring out the factors of 88. Start there.
Okay.
What's next?
Yeah, so 44 times 2.
Next.
24 times 3.
22 times 4. In other words, I'm cutting this in half and I'm doubling this.
Yeah. And then 11 times 6, or 11 times 8.
Okay. Now, does that help? I mean, does it help you to do it your method?
Yeah, this actually helps
your method, at some point in your method, you have to find factors of 88, right?
Exactly,
that do what? That add to 19.
Yeah.
Okay, which of those factors add to 19?
11 and 8.
Okay.
So it'd be x plus 11 and then x plus 8. Cool. And then equals 0, yeah. Cool.
Hold on.
Cool.
We've got 1 minute. Let me give you one more.
Sure. Okay, so won't this one just be x plus 1 and then x plus 1?
Yeah.
Cool.
I think you know this.
Yeah. Yeah, it seems to, I seem to understand it, yeah.
Good.
Cool.
Good luck. You have a quiz tomorrow. Otherwise, I'll
thank you.
Talk to you next week.
Okay, sounds good. Thank you.
Have a good night. Bye-bye.
All right, sounds good. You too.